Hey everyone, my previous stream just died. I have no idea why, but I'm back on another stream, and as you've seen, I'm here working on my VST host app. We're doing from Modalex. It's like an app that it's going to be a free app that's going to run your synthesizer and a few effects and your MIDI effects. Yeah, so we're back after the technical issues, and what I was doing now is I was basically writing a very basic synthesizer. It's going to be just built in so that people can get some sounds. We're getting pretty good. I think we just got to the filter part. Let's see if I can share my screen. Okay, so, right. So, sorry about the issues in the previous stream. So, here are the things that we got to this filter. It runs kind of direct. And so two things that we noticed was important. One is key tracking, and the other is, I guess, an envelope. So let's start by adding an envelope to this. What I would do is I would go to the parameters, have filter parameters, and let's just plainly add an ADSR. ADSR, and then add list. Let's call it ADSR envelope. And then I need like something like an amount, right? It could be an ADSR and how much you want it to affect something. All right, I'm happy to hear that. Hopefully my computer will not go crazy today. So let's do something like this, and let's have something like a let's do percent parameter or percent param ADSR amount or something, env amount. Okay. This is not going to be a super flexible modulation system or something. I just wanted to have some sort of sound with movements, so that we can enjoy the beautiful sounds of the synthesizer a little bit, even though it's not so beautiful. Okay, and then I got the parameters. Let's go to my where's my processor class? All right, so what's going on here is that the okay, so I need to, when I process this, I need to also process the yeah, so I'll need a buffer. I need another buffer to process this envelope in. Another option is I can process this like per sample, like do the sample, but I think this is not going to be so fast. So I might reserve another buffer here in my shared class. Let's have another buffer, or you know what? I can just reuse the oscillator buffer. It doesn't do anything right now. So what I would do is I would first of all This needs to be ADSR processor and ADSR. And then my prepare class should prepare this. Oh, I just realized I didn't do that explain things. I forgot to do this in I forgot to prepare the ADSR, which I probably need to with the regular ADSR. I think it kind of worked because it was 4400 and it happened to have worked, but it's not, shouldn't really work. So node started, and then and then yes, when I start a node, I'm going to do env ADSR node on, or sorry, start node. And when I stop the node, I'm going to stop it, node off. And now, before I process the filter, I can do ADSR or env ADSR process. I believe that's I already have something to, here it is, process envelope. Yes, this is what I need, exactly. So process envelope is, instead of applying this as gain, this would apply this as just save a buffer with these settings. Now, oh yeah, I forgot to mention what does the amount do. Let's imagine that just do the cutoff. And oh, but you know what? I will probably need a negative, not just positive, right? So let's imagine that I'm just going to do cutoff for simplicity, but I'm not going to do modulation of the resonance. But I'm going to add. Where am I? Not in the right plugin, obviously. State plugins synth. Yeah, I don't know if I want to do the percent parameter. I want to do like a float parameter. And it's going to be something like, let's do -1 until 1. Default is 0, something like that. Okay. And then let's go back to my processing class of the synth. Yeah, so the simplest way to do this would be to, now that I've processed the envelope, I can set the strength, and then I can, for sample 0, sample, get num samples, and then what I can do is I can have a temporary buffer here that would be buffers, create subbuffer off filter buff off the buffer in just one sample. Oh, sorry, this needs to be I need the start, so the start is sample 1. So I'm going to process sample by sample, And also have a way to process sample by sample, right? Without this, I don't know. Let's start with this, and then I am going to let's now figure out what the cutoff is going to be, right? So there's going to be a few modulations on the cutoff. So for a start, I would do that, right? So my envelope now is basically 0 to 1. The value between 0 to 1. And this would be, can I use this parameter to just get what the value would be? Because what I can do is I can take something like params filter cutoff. I can get the value between 0 to 1, right? And I should also be able to do convert from 0 to 1, right? Good, that's what I need. Great. So what I'm going to do is let's start with the normalized value, right? So this is the current value, current cutoff equals this. Now current cutoff plus equals this could be something like void o2 and buff equals slither buff dot get right pointer 0. It's just one channel. So envelope buffer sample, right? So this is 0 to 1. Multiply by the parameter params filter and remount. And then I need to current cutoff equals I can just do stud clamp, I think it is, right? Never remember the set of parameters in stud clamp. So I just need to limit this to 0 and 1 after I've done the modulation. So this would be a so value, low and high. Okay, this is the order. So it's current cutoff 0 and 1. And then just process this with this one sample buffer. But it needs to be the current cutoff right now. I'm doing something that's actually not very fast. I probably should do something like, because there are a bunch of atomics here, so let's do something like process filter. This would take something like the buffer, and it can take the oscillator buffer, no accept. Let's do all of this. Oscillator buff. Okay. And then second thing like o2 params equals, this would be now shared params filter, because I just need those. It's good, and I should probably read those before. So let's do something like o2 param cutoff equals this. Ilan says, when are we making plugins together? Ilan is, the people who don't know, Ilan Bluestone, amazing DJ, amazing electronic music creator. Yeah, love to see Elon here. Thank you for commenting here. Okay, so I'm grabbing the cutoff parameter. So I just need to do something like equals param cutoff plus this thing. This is the modulation. Same here. I can just do O2 and amount. Right. I don't want to read those per sample. This would make this entire loop very, very slow. Yes. Hopefully we can meet soon. Thank you so much for coming to the stream. Okay, this looks a little bit better. And then all I need to do is, so I'm calling process filter. I'm running this. Hopefully I've done this correctly. I'm not modulating resonance for now, just the cutoff. So let's see if I manage to implement this envelope correctly. This is pretty trivial stuff. So for those just tuning in, I'm here making a VST host app that loads other plugins. So you can see it loads an instrument. So it loads your plugins here. You can load, some of your favorite instruments in there. It's just going to scan them. And then you can load MIDI effects and audio effects, right? And what we've done today was we just added a few internal ones because I wanted to have, I wanted to make sure that if you get them without nothing, you can still have something to play. So we just made a very rudimentary synth. It might not play because I screwed up something. Let's see, filter envelope amount. Let's see, I probably screwed up something with the values. Oh, I forgot to scale this back. So to scale this back, the cutoff, I need to do params cutoff dot convert from 0 to 1. So actual cutoff. So this is going to be the actual cutoff. It gets scaled back after we've added the modulation and clamped it to 0 and 1 because we don't want to don't want to let the modulation go beyond the range of the filter. Okay, this sounds better than before. Okay. Okay, so I'm not sure this does what it should have done, so it's so weird. It's not what I expected this would do. interesting though. Let's see exactly what I do with the numbers and where did I screw up. So I want the envelope buffer times envelope amount, right? Because this is 0 minus 1 to 1, I believe. Sorry, this is minus 1 to 1. And then, right, so if it's 100%, param cutoff is get value. That's the 0 to 1 value of this. So we should be, oh yeah, we can just debug this and see what kind of values came in here. Envelope sample, create buffer, start from sample to 1. That makes sense. Okay, so envelope amount, that's fine. Current cutoff. Okay. Oh, I need to set the parameters on the ADSR, which I didn't. So this needs to be envelope ADSR dot set parameters, right? Params ADSR params yeah, ADSR get params. So it's not processing with the right parameters at all. No, maybe I did. I didn't. No, this needs to be here. This needs to be in the when the node started. So the node started, I need to do just like I did here. Set parameters, filter ADSR. This looks very well. Look at this beautiful modulation. I think it's pretty good. I think this is pretty good. Okay, I really like this. Let's store this and keep adding the next thing. Close the synth, do this, and then live chainer synth, edit cutoff envelope, cutoff modulation envelope, and we just need to add key tracking in a saf dar here. writes me all these formulas, but I have no idea how to use these formulas. This is about or there's something about key tracking, I think, but I'm not sure how to understand this. Okay, so now let's do some key tracking. Let's see exactly what I did with key tracking in my in another plugin. Okay, so just did an offset of the what's frax? Is that the actual frequency? Yeah, so I just did I just took the frequency and added offset times the frequency. Let's try this. All right, so I'm just here with the stuff on the chat. It tries to explain to me how to do proper key tracking. So I need to think of what would be the best way to just do this this thing. So Saf tries to write me some math that I've not understood just yet. While I do this, I'll try something simple, which is yeah. So this just took the frequency times what's this key tracking 0 to 1. Okay, so I think this here I just added the actual frequency. Let's try that. See how that works. Synth, let's do so let's try something. First of all, let's put the music back. Okay, now let's try filter. Let's do I think I can do this as a percent parameter or something, right? So let's do key tracking. Safir is trying to explain to me math, which I don't understand. Okay, so Saf wants to come here and help me understand the key tracking. Let's see if we can add him. Hello. Hello.
So now you should be able to hear me.
Yay!
All right.
I'm looping myself though. There's a.
You're looping. You can hear yourself.
Hello.
Okay, let me just.
Okay, I think it's okay now.
Headphones, and then nobody will hear nobody. 1 second.
So for those who are just coming in, we have Safdar Sagol from Polyverse.
Okay, can you hear me?
Yes.
Can you hear yourself looping?
I don't think so. I think it's okay.
All right. Cool.
You're pretty far away, but you're okay. Like the audio.
Far away. Let me make it even better.
No.
Here we go. Oh, now you can hear me.
Okay.
Better?
Yep.
Yeah. All right.
Right.
So
we were talking about key tracking for the filter.
yeah, it's not just key tracking. It's not just key tracking. It's all of the modulation goes through, needs to go through a conversion from pitch, or more like it has to be treated as if it's pitch. So let's say you have an LFO. When it goes up, you want it to go up an octave. When it goes down, you want it to go down an octave. You don't want it to go up 100 hertz and down 100 hertz, because if your filter is tuned to 100 hertz, it will be between 0 and 200. Or if it's 200, it will be 100 and 300, right? So there is one very basic algorithm to turn pitch into frequency, and everything has to go in there, including the pitch tracking, okay? And that is 2 to the power of the cutoff modulation, which is what you're going to put in, like the notes and all that stuff, and multiplied by the center frequency of your cutoff knob, right? Or your center keyboard note, doesn't matter. So let's say your center frequency is E, right? Usually in the keyboard, 64 is E, right?
Okay.
So you multiply it by that hertz number, and it can be normalized hertz, or it can be just like plain old hertz. It doesn't matter, because you just multiply it by a number. And if you plug into that exponent, basically 2 to the power of...
Let's go a few steps backwards.
Yeah.
Usually, the way I've always used in synthesizer and stuff, there's two things. There's the modulation the modulation is an offset on the parameter value according to the range of the parameter. Like to me, 100% modulation takes the parameter from the beginning to the end, like serum. It's 100%.
It's not correct towards anything.
I'm just saying that's how it works in synthesizers that I'm usually using.
It doesn't work like that.
And I'm talking about like regular modulation, not a key track.
Not on frequencies. We're talking specifically modulation on a frequency parameter. We're not talking about amplitude. We're not talking about anything.
Yes,
but a frequency parameter. A frequency parameter does not go from 0 to 1 in normal synthesizers. Okay? Because if it were, you'd be able to modulate it to go below 0, right? Because if you have something on 0, you think it would be clipping, but that's not true.
What?
In a frequency of a synthesizer, you can go lower and lower and lower to infinity and never reach 0. And you can check me up on that.
I'm just saying the modulation that I'm used to. It's again, there is on the actual parameter. There's still, there's the exponent, whatever that gives you like the frequency.
Have you ever seen a synthesizer that has 0 on the bottom of the frequency knob?
But it's not what I'm saying. When it's saying 0 to 1 is just a parameter value. Parameter gets
parameter 0 to 1. Okay.
Yes, and the parameter is what's being modulated. Then you put it through the exponent or whatever to get the frequency.
You can do that as well. It doesn't matter.
Yes, right. So this is what I'm doing. So let's talk. What I'm trying to say is, to me the modulation and everything, those don't matter. I already have those both in 0 to 1, and I have the function to convert them to frequency.
You are plugging that into the hertz, right?
No.
I don't want you to plug that into the hertz.
No. That's all modulation stuff done 0 to 1, and then when it needs to, it gets converted to frequency using the
exponent.
Whatever I have like some whatever it's called, like some skew of like the parameter. There's like a frequency shift.
No, that's what I gave you. That's the exponent.
But I'm just saying I already have the exponent of doing like I have it. It's been calculated. It exists. I have the.
Okay, then if you have it, what is the range between 0 and 1 in pitch, in octaves? What is your range?
Are you saying what my range again? The keyboard has a range of the keyboard. The filter has the range of the filter goes way higher.
The cutoff knob. The cutoff knob. What is the range of the cutoff knob? Okay. What is 0 in hertz and what is 1 in hertz?
Okay, so the cutoff knob is, let me see. The cutoff knob is, let's see. So the cutoff knob, where are you? Okay, so 0 is 10 hertz and 1 is 20,000 hertz.
You have 11 octaves?
Maybe. I didn't count it by octaves. I didn't think about it as octaves. I just thought about
it's octaves.
No, I know. I'm just saying whenever.
Can you change that?
Sure.
Make it between 20 and 20.
Sure, I can do that.
This way, your center is going to be E.
Okay.
Just like your keyboard. And when you add key follow, it's going to just go around the keyboard like that.
But here's the thing. I think you're overthinking this. I already have a function that calculates the frequency. I don't need to recalculate it. It exists. I have a function that takes 0 to 1, gives the frequency. I don't need to redo that for other things. I want to.
So you can plug everything in there.
Yes. So
you can plug your note number in there. You can plug your LFO in there, your envelope, whatever you need.
Right. So that I can do. So what I can do is I can say, well, the notes, take the note between, like for example, map it to. The only thing is that the frequency range of the keyboard is a little different. right, than the one on the thing.
That's what I'm trying to.
Yeah, so I could do something like map.
If you put it between, now you have 11 octaves between 10 hertz and 20 kilohertz. It's 11 octaves. Okay. If you, whatever you put in there, you divide, say, by 11, every one that you input into that division will be an octave, right?
What do you mean by every one? What's a one?
Number. 0 to 1, it's an octave. 1 to 2, it's another octave. Each time you add a number, you multiply it by 2, the hertz.
I'm confused about this number thing. Which number? Number represents what?
So that's the problem with saying, hey, I have something that converts it for me without actually understanding what you're trying to convert. Okay? Let's talk about the exp2 for a second, and you'll get everything will click into place. This is the most important function in your synthesizer, right? Exp2, if you give it 0, it's going to output 1. Okay? If you give it 2, it's going to if you give it 1, it's going to output 2. So basically, 0 input into the exp2 times any frequency does not change the frequency. If you feed it 1, it will take that frequency and multiply it by 2, giving you 1 octave up. If you give it -1, it's going to output half. So it's going to lower down by an octave. So that exp2, each time you add one number, it will add 1 octave. It will multiply that signal times 2. So now what you have there is you have 11 octaves. You got before the exp2, you basically have something that multiplies. You have you don't have a center frequency because you're going between 0 and 1, right? I like to go between -1 and 1. I like to take the cutoff knob and make it bipolar because I like to have a center frequency to my cutoff. But what you had is from 10 multiplied by 11 into the exp2. You can take any signal like your MIDI notes, which is 12 for 1 octave, right? 12 numbers, 12 whole numbers for 1 octave. You divide it by 11 because you had the 11 octaves inside there. You divide your note by 12 because you have 12 notes per octave. And now you can input it into that number to get a nice key follow.
Yes, but I want to take the pitch that's in hertz because I want to treat pitches that are between the notes as well, like pitch shift.
Yeah, you can do that.
So I would like to use the input number in hertz that I already have because I have the note in hertz. I don't need to calculate it. That's the part I'm confused about.
First of all, what are you trying to do between the notes?
I want that, for example, if I'm doing a pitch shift, like let's say I do an octave.
Pitch shift or pitch wheel?
What's the difference? The wheel is like
there's a difference because pitch wheel is another modulator. Has nothing to do with the note numbers.
Right. I don't want to look at the note numbers at this point.
Do you get the pitch wheel into the frequency output of the keyboard?
Yes. At this point, where I am in the code, there's no note. There's frequency in hertz for the note. That's what I have.
And you get that pitch wheel over there?
Yes.
It's already automatically modulating?
Not magically. It's every time there's a pitch wheel, it gets recalculated and you get the frequency. That's how it works. That's how. For example, that's how do I have pitch modulation in a juice synthesizer now? Like I have the every time there's a pitch wheel event, you get a new note basically with a new pitch, new frequency. So I have frequency. So whenever I'm calculating this filter or whatever, I already have the frequency including all the modulations. By the way, that includes other modulations that I might have on the pitch, right? If I have like unison.
If you have a frequency to add to the frequency, you're fine. You just make an offset in frequency and do that. But the problem with that
so that's what I did
is that it's dangerous.
Why?
Because you can reach negative frequencies if you don't modulate it correctly, right? If you're if your cutoff is tuned to 10 hertz
Mm-hmm.
and you try to take down 10 hertz or 20 hertz with your keyboard.
So you limit, but I don't even I don't even do negative cutoff. But yes, if I would do negative, I would limit, right? Just limit, just like by the way, just like I limit the modulation. But I have the modulation here is my modulation is 1 to -1, right? So my modulation, in theory, you could be.
I'm not sure if you can actually do that. Now that I'm thinking of it, you can't just put in like you can't use it as an offset. It's not going to work.
What do you mean?
How can you do that? The only way I know how to control both with the cutoff and the frequency is inputting the notes as notes. And treating the cutoff as note, the notes as notes, the LFOs as notes, the envelopes as notes, and taking all that bulk and transferring that into hertz.
Yeah, but I don't want to work like this. This is too different from how I currently work. So I don't want to change
That's
how I work.
the only way
I
I
don't want
think
all my functions to do this. So I want to find a way to do a frequency offset.
Pretty sure you can't.
I don't understand why.
I don't know how you can.
What do you mean?
If, say, you're playing 440, okay?
Mm-hmm.
And your cutoff is, I don't know, at 10 hertz.
Okay.
Are you going to subtract the cutoff from your note all the time? Is that what you're going to try to do?
Oh, no. I think it's something else. My understanding is it's what you're doing is you get the again, I'm not sure that's how everything works, but that's my understanding is how it works, that you take the frequencies, you put it to normalize back according to some scale, just saying, well, there's some
It just gave you the scale.
Yeah, but it needs to be a scale that's continuous, like not
it's continuous. All right, it's continuous. What I gave you is completely continuous.
But it needs to be continuous from frequency. Like let's say the frequency changes, the offset of the filter needs to change. Does that make sense?
Yeah, that's what I said. If you give
so
notes can be interchanged with frequency if you bend it the right way, right? But the difference between notes and frequency is that with notes you can go down and down an octave and down an octave and you'll never reach zero, right? You can subtract forever until you die. You're never going to reach zero. With frequency, you can subtract and not only you reach zero, you reach minus.
Sure, but okay, so I'm just saying this. The formula we need is something that takes frequency and
transforms it into note and back into frequency.
No, doesn't need to be note. This needs to be a scale. Like it needs to be a graph. It's not a linear graph. It's like a log, right? In this case, or an exponent graph, like right. That needs to convert this into.
You can log it into a frequency and exponent it back. But it's like going around.
No, why? Because if I already have the frequency, the cutoff as frequency and the note as frequency. Hang on a second. I have this thing.
By the way, you already transferred the note into frequency. I mean, you already have a conversion there, so why do it there? Why not do it in the right place? Notes come to you as a note number, not as a frequency.
They come to me as a frequency.
From where? From somebody who converts it for you.
No, we can talk about this where it happens. So it happens in the Juice MPE notes. it gives you like it already. So if you can look at this function, it's called MPE nodes. Get frequency in hertz. So let's have a share in this. Where's my screen? Okay, so this is the function that uses, right? It has.
Hey, you see POW2. You see in line 83. That's what I'm telling you to do.
Right, but I'm just saying I already did it. I have it already.
I'm saying it's not the right place to do it.
What is not the right place?
Not here. You should do it only once.
I did it only once.
No, you're doing it twice.
I'm doing it literally only once.
No, I can show you another place that you're doing it. When you're transforming the cutoff knob to the frequency of the filter.
Yeah, but I'm doing the pitch, but I'm doing the pitch for the oscillator too. Like this is
This is for the oscillator. This has nothing to do with the filter though.
Yes,
right?
I'm not doing it twice. The one place I'm doing it for I'm currently using the same place for the oscillator as it is for the filter. Like I'm using I take a frequency number and I pass it along for all the oscillators for different things.
You'll have to do the same.
I have a number that goes into all the functions.
Okay, and how are you going to have like a semitone and octave knob for the oscillator? It's the same thing.
Sorry, like an offset? Okay,
Yeah.
so for the offset, let me show. So for the offset, I wrote my own functions. So I have something called so I have all these conversion functions, like sense, for example, like offset. So this gives me the offset in sense if I need to do tune. Right. This is how I tune, for example. Like I do. I have this thing, right, that gives me.
Woo. It's hard for me to look at. Sorry.
Why?
Because again, you're deconverting the conversion that it was unnecessary in the first place.
This is not something that happens in my synth. This is just a function that I have.
The fact that somebody coded something doesn't mean that you have to use it.
Okay, but again, I'm just not understanding I don't want to have conversions in a scale of values that I don't understand. To me, I need to.
So listen and understand, and you'll see how simple things are. There's pitch on one side, frequency on the other side. There's one algorithm to convert between those two. Master that, and you don't have to deal with those crazy conversions that are completely insane.
I don't know. Again, these are not what I called in my synth. It's just helper functions.
It doesn't matter. Those helper functions are not to be used. You don't need them.
Of course I need them. How else am I going to do sense? If I need
I'll tell you exactly.
Okay.
Let's open a new file, okay? And let's write very basic algorithm.
Okay, let's go.
Okay, this algorithm is like so. STD נקודתיים exp2, yes, colon, exp2.
Mm-hmm.
Or you can go power 2 to the whatever. You can go pow 2. No, pow, and inside the first variable is 2, and the second variable is your cutoff mode. Okay, call it cutoff mode.
I don't understand mods here. I just need nodes to pitch. Mods is to me completely unrelated.
This is pitch input.
Of the filter.
Pitch input.
Of the
call
notes?
it whatever you want. This is pitch in octaves. Okay.
I don't understand what that means. Pitch in octaves. Give me a number.
A number 0 will give you no change. Number 1 will give you an octave up. Number 2 will give you 2 octaves. How do you want to call it?
Okay, I see what happened. Okay, so you look at like a relative note, like on the keyboard scale.
Yeah,
what you're talking about.
Yeah.
Okay.
This is a modifier of your frequency. This is going to modify your frequency.
Okay.
So I don't like to use POW. I like to use exp2, which is basically POW 2 to the one number goes in there.
So
exp2, and whatever you put in here, is basically your cutoff or your pitch or whatever you want to call it in octaves. In musical notes, octaves. Okay? So put an X there.
Okay, so you're saying
Call it X. Put an X. Okay. And then multiply that by frequency.
Okay, so
Frequency, call it frequency.
okay,
Okay. Now this frequency can be your center frequency, can be the bottom frequency, can be the top frequency, depending on what you're going to put inside the X value, okay? If we want to treat the X value as if it's keyboard notes,
okay,
right? Then we will just divide it by 12. X divided by 12 is now, every note is going to give you a semitone.
like here.
Yep. This is a conversion between semitones to frequency. Now, let's look at, make a value called note number.
Okay, so double note number.
Okay? Your note number right now, let's say it's in the middle of the keyboard, it's 64, right?
Mm-hmm.
This is the note E.
Okay.
Now, if you see, when I plug in note number instead of X, I need to give it an offset because I don't want the middle of the keyboard to modulate. So what do? I say X is going to be note number minus 64.
Okay, so X is going to be note number
minus 64.
Okay.
Okay, now X is going to give me an offset from whatever frequency I choose, whatever cutoff the knob was on, or whatever frequency you deem to be the center frequency.
Mm-hmm.
Okay, I would say cutoff frequency, right? Because cutoff can also be cutoff pitch. And note number is note number.
So are you saying this is the function?
This is the function, and get this, it's very nice because your cutoff frequency can be normalized or it can be in hertz. It really doesn't matter because what you're doing there is just multiplying the frequency. So you can take 100 hertz and multiply it by 2, it's going to be 200. Or you can take normalized frequency 0.01, multiplied by 2, it's going to be 0.02. So whatever you plug in there, it's going to move that frequency by notes.
Okay. Now let me do something else. Okay?
Wait. Let's continue because we can continue and see how
I want to see
useful
what numbers
this.
come out of this. Wait. Hang on a
Okay,
second.
go for it.
I
Do
mean,
your experiment, and then we'll continue
Yes.
and look
Now-
at how we want to put a knob in there, or an LFO, or an envelope.
Yes. So I want to look at something more basic. I want to look at this. I don't need this value. I want to know.
You can actually put, instead of note number and X divided by 12, you can say get cutoff frequency, and then double instead of note number, you can call it octave.
Yes. Hang on a second. So here's the part I want to understand. I'm calling this question because I don't know what it means. This is the part. Let's ignore cutoff. I want to know double note num. Okay. And I need to. I need to understand what each I want to use this number here. I want to understand what this means. So I want to see, for example,
Instead of note number,
hang on,
backwards
hang on
and
a second.
make it by octaves. This way you'll see exactly what's happening.
Hang on a second. I want to know. So you did 64 because 64 is like the middle of the keyboard, right?
Yeah.
So mid keyboard. I need to know what each number means. It's going to take time. I'm sorry.
Good.
But, I did 12 because 12 is notes per octave,
Yes.
right? Okay. Okay. So I'm just going to do something like this. I want to do, I just want to print out the numbers that I'm seeing from this. But I don't know.
If you input the number 64, then you should be getting back the number 1.
See some range.
Oh, go until 76.
Okay.
Including. So go 77.
Okay.
And an octave below 64 is actually 52. So you can start from 52 instead of 45.
Okay, let's. I want to see what kind of numbers I'm getting here. So maybe you can explain this to me. Oh, oops. Okay. So what are these numbers? What do they mean?
These are multiplications.
Okay.
That you can multiply any frequency to get the interval that you see over there on the right.
So
right, 64.
Okay, now I'm starting to understand. Okay. Now we're talking. So 64. So this is supposed to give you between 0 and let's see how much.
76 is your next octave, right?
Yes. I want to see the entire, all the numbers, please. So okay. Okay, so this is giving something close to 0, right? It kind of curves towards 0.
It never will reach 0. Never.
Yes. Yeah, but it curves. It kind of bends towards 0, and then in the middle.
And then it explodes.
Exactly, and then in the middle I get 1, right?
Mm-hmm. Which means it's unchanged, because when you multiply something by 1, it's unchanged.
Okay.
Let's do it even simpler. I think you should look at it even simpler.
Yes, but what are those numbers? This 38 thing.
It's if you multiply it by 38, you'll reach note 128, which is I don't know how many octaves is it. 32. It's 8 octaves, right? I don't know. How many octaves do you have here? 7 octaves. 1, 2, 4, 8, 16, 32. 5 octaves.
Okay. But I want to know what exactly does this mean?
Okay. Let's simplify it. Okay, it's very easy to simplify it. Let's remove the term note number and change it with the word octave.
Okay.
And let's remove MIDI keyboard, notes per octave, all of that stuff. And instead of X, just write octave.
So just write this.
Yes.
Okay. And then what else?
Everything is deleted. Yes. That's it.
Okay. So you're just giving this is just the exponent value of the note.
Yes. Not the note, the octave. Okay. So now let's start looking at octave 0.
Okay.
Give it the numbers -4, -5, -5 until +5. Okay.
Just to give you, I really want to keep this as reference.
Yeah, keep it and make a new one.
Okay. So
you forgot to write note number there, but okay. It's still octave instead of MIDI note. Yeah, there we go.
Okay. So what does this function do? Is this like just like an?
It takes in an octave value and spits out a multiplication that you can multiply by the frequency, and then we'll take some frequencies and multiply it by them, so you'll see how it treats them.
So basically, you mean something like this, and it does this.
Yeah, and just octave without the division.
Just this?
Yep.
Okay.
And now you're going to feed it with a following numbers: -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5.
Okay. So this. Yes?
Mm-hmm. All right. So now you can see that the value 0 will keep your frequency unchanged when you multiply it by that, okay? You multiply something by 1, it's unchanged. If you go -1, it's going to be halved. -2, it's going to be quartered. -3, it's going to be an eighth of that value.
Okay.
You see how it's halving itself? Each octave, it's halving itself.
Mm-hmm.
And the same thing happens when you add an octave. You're multiplying it by 2 each time. Multiply by 2, multiply by 2, multiply by 2.
Yes.
Okay? Now, let's look what happens if instead, if we multiply these numbers by, say, middle, like a nice middle E, which is 659.3 hertz. Okay, so multiply that, what you get out of octave, multiply it by 659.3.
59.3?
Yes, and that's nice because this is an E5, this is not an E4. But look at the output of the numbers. You have between 20 hertz up until 21 kilohertz. It's basically the hearing range with E smack down the middle.
Mm-hmm.
So now you have 10 octaves of range, of usable range, right?
Mm-hmm.
You can take your MIDI keyboard and just input that into the octaves, divided by 12, and you'll have key follow. You can also take a bipolar knob between -1 and 1, multiply it by 5, right? Then you'll have -5 to 5, and have a continuous control between 20 hertz to 21 kilohertz, which is incidentally your sample rate and audio range, hearing range. It's just like classic. That's what most synthesizers do.
Okay.
And then you can also take an LFO and modulate it and say to the LFO, let's multiply the LFO by 1. And then I get an octave up, an octave down, an octave up, an octave down. Let's say it's a square LFO, right?
So wait. So I want to ask you something. So what you're saying is, if I understand you correctly, so you're saying if I'll take a 0 to 1 and I map it to -5 to 5, or right, inclusive, right, linearly mapped to -5 to 5, then explain this should give me like a good range for any
nice
kind of
travel for the key. Yes, a nice musical travel where when you have on the center you'll have E5, and then you can go down an octave 5 times, and the ranges between those travels will always be 1 octave, and you can divide it into 10 octaves, like 5 on this side, 5 on that side, and get all of that nice travel range. That's what we do in Filterverse as well.
Okay, so wait a second.
But not just us, everybody does that. That's like the golden standard of...
Okay, so let me write this in my way for a second, okay? I have this file here called pitch utilities. It's templated stuff and everything. So let's write this in this way, right?
But wait, before you write it.
Mm-hmm.
I want to put it to you that you should not treat your cutoff knob as 0 to 1, but -1 to 1. And why? Because you have modulators that go between -1 and 1, namely the LFO.
Mm-hmm. They'll go
and
from -1
you expect the LFO to cover the entire range of your cutoff knob, right?
Yeah, but I don't think it matters. It's all relative.
It just makes things easier to have the parameter that you're using use the same range as the modulation that modulates it.
No, I don't agree. For me, it's always better for the parameter to be 0 to 1, and the modulator.
The parameter in the host side, yes. But in the DSP side, where you start calculating the modulation, it's nice to have it 0 on the center, -1 on the extreme side, and +1 on the other extreme side.
I don't know. I like to do the modulations -1, and that's also, I think it makes sense, because then to me, when you do a full range, it makes sense that it gets you like
Listen, you can do whatever you want. I'm telling you what the standard of synthesis is. I didn't invent it. If you go to modular synthesizers, LFOs are between -1 and 1. Why?
Right.
Because
Right.
it's a bipolar signal.
No, I do -1 to 1 as well.
If you take an LFO
But
and you
but
add
envelope,
it,
but envelope I do 0 to 1.
envelope is unipolar.
Yeah, that's what I'm saying. So I have to me values are 0 to 1.
But envelope
LFO
starts from the
is
bottom.
-1 to 1.
LFO starts from the bottom.
Right. So LFO is 0 -1 to 1 as well in my code.
LFO is -1 to 1.
But
LFO is
the value of the
bipolar.
parameter is 0 to 1, and the envelope that's it makes sense, because envelope, unless you put something in it, envelope will take the value higher.
Envelopes and unipolar signals sometimes will have to be multiplied
Yeah, exactly.
by twice, but you'll always have to tune the cutoff to the bottom in order to get like the entire range.
Right.
Unlike an LFO where you want to center it.
Exactly. Anyway, back to what I'm saying, because this I'm trying to understand. So you're saying I should do this, and this says Octave expects a musical range of let's
One
say
octave. 1 octave.
No, but you said it's like
As many octaves as you want, but 0 to 1 is 1 octave. No. Be careful. This is incorrect. We put a nice center frequency in order for this to happen. Okay? If you put -5 to +5 and you put the frequency on 20 hertz, it's going to, like, half of it is going to be unusable, right? So this will convert an input of octaves, like note octaves, intervals. Woo! This will give you an interval of note like musical interval octaves, and it will transform it into something that you can multiply the frequency with.
Sorry, I lost you there. Can you say it again?
The output of this function is something that you multiply a frequency value by.
Okay, so get frequency multiplier.
What I like to do is call it frequency modulation, pitch modulation. I call it pitch modulation.
Okay.
And I have two inputs to that pitch modulation. I have the frequency and then the octave. That's right. And in here, I just multiplied by the frequency.
But I can assume the one from the other, right?
No.
Why not?
Because this is an interval. It's not a note. It's an interval. This gives you an interval to the frequency.
Okay, and then how you do the modulation? You did this plus frac?
Not plus, multiply.
Like this?
Yes. And this, the frequency, it doesn't matter if it's normalized or hertz. It doesn't matter. You can use any kind of frequency signal. Okay? So you can give it 100 hertz. If you put in octave 1, it will give you 200 hertz. If you go in octave -1, it will give you 50 hertz. If you go 0, it will give you 100 hertz.
Okay.
So it's a multiplier. So you input the frequency, you input whatever you want to move the frequency by. How many octaves do you want to move this frequency by?
Okay.
And you get your result in frequency. In frequency. It will return another frequency that is X octaves above this frequency.
Interesting. Let's try something.
Right? So if you want to put in note numbers in there, you just divide them by 12 and give them the offset, so you don't just climb up, you can go down too.
Let's try something here.
By the way, I really liked how David Frick said this was one of the most intense developer discussions I've witnessed in a long time. Well, well, that's just two Israelis speaking, and also two very good friends that are not afraid to challenge each other and learn from each other, because I've learned so much from Eyal. Wow. And we have the most intense discussions, but really for us, it's an everyday thing.
Yes. Okay. So, but the thing I'm trying to understand more is how this is like. So I want to because I have this thing. Let's see. Let me think about this for a second.
You probably have this somewhere already.
Yeah, the thing I'm still trying to understand is, do I have a way to make this more streamlined with the range of values that the octave expects? Like maybe I do something that
you can make a new one, divide octave by 12, and say, but instead of octave, it get note. Right? But I like it in octaves because it's really helpful to me to think of one being an octave.
Yeah, the main thing I understand is how do I convert the frequency of the modulator to octave?
You don't take a frequency from the modulator.
No. I would like to convert.
You put in note numbers from this and add to the note numbers pitch bend. So pitch bend, if you enter a pitch bend plus note number, you can decide how many notes the pitch bend is going to be, right? The pitch bend is between -1 and 1. And if you divide it by 12, it's going to give you notes. So every one is going to be a semitone for you. You can multiply it by however notes you want to set up the range of your pitch bend.
Yeah, I think I have something like this somewhere. Let me have a look for a second.
It's not the job of the MPE to do that.
No, but it does know the range, right? So
that's why I'm saying I'm not sure if the MPE should be telling you what's the range of your pitch bend. No, is that part of the MPE's job?
No. This is already how it works. Yeah, it already calculates the. But by the time this arrives, I mean this thing is just a structure.
By the way, look at the algorithm. It's exactly what we wrote.
What? Okay, right. So yeah. So the part I'm trying to understand is, let's see, how do I make this usable?
You just have to do it in one place instead of having it done in a different place and then convert it from to. So you have initial note is basically your MIDI note number, and total pitch bend in semitones is the pitch bend times how many semitones. For us, for instance, we have a different range for up pitch bend and down pitch bend, because you know how Erez likes to have his pitch bend up by 2 semitones and down by an octave.
Yeah. But and by the way, I totally understand that. By the way, but
so this is your pitch, and this is your note. Yeah. That's it.
And I think it's already double. So I think this would give me the exact the number we're talking about. This would give me like an
Basically, this is what you need. You need initial node. You don't need the frequency of A because you need to join the LFO, the envelope, the keyboard, all of those, and plug them into this algorithm.
Right. So I'm just saying, I want to understand, how do I convert this into the octave range you're talking about?
This is already converted. You see, the POW2 on line 83, that's exactly what we wrote. So you only need line 82. You don't need line 83.
Right. So I'm just saying, this would give me something like,
pitch and semitones.
Yes, I'm just saying this. Let's say my note is 64, so pitch with pitch bend it would be like whatever 67, right? 66, really some other number. Or
and then you see on the bottom they remove the 69 to kind of center out. I don't know why 69 specifically. 64, 5, 6, 7, 8, 9, 10, 11. What? 9 is A? 64, 5, 6, 7, 8, 9. It's like A, the note A4. So in here, the frequency is centered around A4. Oh, and it gives you frequency of A. There you go.
I'm still trying to understand, how do I get this into octave range? The one you were talking about. I have it like in some
divided by 12. Right?
Okay.
MIDI note number is 12 times the range than an octave needs to be, right? Because you have 12. Every whole number is a semitone. You want every whole number to become an octave, so you divide it by 12. Okay. Just like it's divided in line 83.
Okay, so let's go back in this. So how about I would do something, instead of doing octave, I would do something like
semitones. You can do that.
Right, yes. So now we're talking, so something like semitones, and this would be something like semitones. Well, okay, semitones.
Divided by 12, yeah.
By 12, right?
Yep. But now it's a little bit less generic. Now it's specifically for an input that receives something between 1 and 0 and 127, right? But this is useful also for modulating anything that you want. So if you say my range is going to be 10 octaves, so you multiply whatever goes in there, like the envelope, and then the amount of the modulation, you can actually set it by semitones or octaves or whatever you want.
Okay.
Oh, but if you're going to say pitch modulate note num, I would add another value, which is going to be keyboard center, right?
Mm-hmm.
And I would give it a default value of 64 or 60. Some people like to use 60 as the center of the keyboard, right? Middle C, C3. Okay. What do you like?
I don't know.
What is the center of the... I think it should be the center of the cutoff knob. So when you double-click the cutoff, it centers itself. And then when you go full key follow, it will give you the exact note that you expect, right?
Yeah, but the numbers I'm writing here are pretty generic. So explain to me the center thing.
So if note starts from 0 and goes up, right?
Mm-hmm.
But your keyboard, you want it to have a center and go up or down from that center. So that's going to be like an offset. Say you have a key follow, right?
Yeah, by the way, so let's...
You want part of the keyboard to pitch it up and part of the keyboard to pitch it down.
Right. So and are you saying that's because do you want us to have this range of like 0 to 5, minus 5 to 5? Sorry.
Minus 5 to 5 is the entire range. Like 10 octaves is an entire range of our hearing range between 20 hertz and 20 kilohertz.
Right.
So, I mean, that has nothing to do with the range of the keyboard specifically and the notes between 0 and 128. It does. I mean, you don't have to adhere to a specific range. That's what I'm saying.
Okay.
But do you understand that if you're going to say, give it a note number of, say, 60 right now, 60 is how many octaves?
Yes.
0, 12,
this is just
24, 48, 36. It's going to be like 6 octaves up.
Right. That's what I'm saying. This is only gonna give me like an up value instead of giving
That's
like
right.
up and down.
So you want to say note minus 60.
But you know what? Actually, I think the up is correct. So the way I've done this,
if you start from 20 hertz, then the up is correct. But if you start from a frequency value of your knob, and you want the knob to be default to center, then it is incorrect.
Yeah, the way I understand keyboard tracking usually is that it starts from the knob and then opens up.
No. In no synthesizer that I've ever heard of.
You're saying it also closes down, like it's two-sided?
Yes. And you can say my filter's center frequency is C. Or you could say it's E. I like E because I feel like the ranges of minus 5 octaves and plus 5 octaves is very wide. If you use C, you can go to the previous program and give it a C. I'll give you the value 1 second. The value of a C, C5. It's 523.25. So you can go to the other program and print out, and you'll see the range of this 10 octaves, and you'll see. It's not the best range in the world. Try it. The program that we coded before, just a second ago.
Yeah, but what do you mean? Like, what's not good about it?
I'll show you. Look at the values.
Okay. So what did you say I should do?
Instead of 659, which is 659, by the way, is E5, 659.255, yeah? But C5 is 523.251.
Okay.
And now it's going to spread out those 10 octaves for you, and you're going to see it reaches from 16 hertz to 16 kilohertz. And that's not a great range for a cutoff. Right? You want your cutoff filter to open up. And by the way, notice that a lot of synthesizers do this stuff. They put their center in C, and then their cutoff frequency, the cutoff knob, doesn't open all the way, and it kind of sounds dark. The synthesizer will sound dark. Does that make sense? You can go and say, you know what? Let's do it between minus 5.5 to plus 5.5.
Oh, but
you do index.
No, but for
just
example,
go in half steps, right? You can see out twice each time.
Yeah, right. As in do like half steps or something.
Yeah. But start from 4.
But we also need
minus 5.5 minus 6. You want to start.
Sorry.
You want to start at minus 6.
Wait, I'm confused.
So it starts. So you can start counting from minus 5.5 if you really want to. But I think that's what they're doing. That's why they got this 11 octave range. Weird number and so unmusical.
Yeah. So all this stuff left me even more confused. Honestly, I just don't understand. I don't understand how these numbers, how you work with them, because again, I just don't work with this.
Yeah, of course you do. You've seen. You have the same algorithms on your end. You just need to understand that you have a frequency and you want to start moving it by note numbers, and this is your algorithm. That's it. Not note numbers.
I'm still not sure what my algorithm
musical intervals.
I'm still not sure what my algorithm is.
x2 of x times the frequency.
Okay, but I'm still not sure what I'm still not sure. The x is the part I'm still not sure about.
You give it an interval, a musical interval, and it gives you back a new frequency that is that interval apart from the frequency, or the original frequency that you gave it. Right? So let's look at how a normal synthesizer algorithm would work to modulate it. Okay? I would give it like a center frequency of E4, the one that I told you. It's 600 and what? That's what I like to do, right? Where is the note number? 659.255 or 225. Let's see. Frequency to note. And by the way, this opens up a whole possibility for you to kind of retune your synthesizer and so on. You don't have to be by 440. You can also go for 32 or something sexy like that. So for E5, it's 659.255.
Okay, I'm sorry for this, but I'm still not sure I understand how to work with this valve. Let's go back. I need a number. I have a 0 to 1 value for the key tracking. I need to do it for something so that it offsets the frequency of the filter.
Yeah.
What do I put in? What range of values?
Wait, key tracking, you want it on 0, no key tracking, and on maximum 100% key tracking, right?
Yes.
Good. Where do you get your frequency from?
The frequency of what?
Where's the filter? Where does the frequency go to?
There's a process function of the filter, and it takes a frequency in a number. Right?
Okay, show me where you're actually sending it.
Here. So, here, filter process, cutoff frequency. This is post modulation, post everything.
Cutoff, convert from 0 to 1. What does that do?
Yeah. So the parameter, right? I have a parameter. I have a frequency parameter, and I'm using the same skew post modulation as if a user put it in. Like it's the same skew. My frequency.
What is the convert 0 to 1 thing?
It calls my own conversion. So this thing does. Let's see. So it calls a custom function in this case, but the function is. Let's look. Frequency parameter.
It gives you an actual hertz?
Yes. So yeah, so I'm using a skew function. So I'm using a skew function with a center. That's how I'm doing the frequency. So I give it a center. So for example, this frequency, this filter particular is 10 to 20,000, but the center is 2,000 hertz.
That's not pitch.
I'm not saying it's pitch. I'm just saying this is.
So that's not a nice curve to have.
Okay. So
it's not a good curve.
So what do you think is a good curve?
Just told you. The center should be 659.255, and that's basically a middle E. And this will not give you that curve that you're looking for because it's not the right algorithm. And you start from 20 and reach 20. This is not the way to do it, though.
Okay.
For your frequency param, what I would do is keep it between 1 and 0 and 1, or minus 1 and 1. We can debate that.
0 and 1 and 1 exist in the system. This is something else. This is actually the value.
And
right?
this I would not use within the DSP at all.
What do you mean? It's a function. What do you mean by not use it? Eventually, there's a function.
I would use the actual normalized not normalized value. I would use the parameter value to move stuff around.
I am using the parameter value to move stuff around.
But you're using the hertz values that are coming from this weird skew for center thing.
Well, at some point, I need to convert it to hertz. The filters I'm using.
Yeah. Let's convert it to hertz, though, but not here.
I'm not sure what's not here.
So let's go back.
I'm using the set skew for center function that's using a log function.
No, you don't need it.
Okay.
You don't need it.
So
we have the X for that.
Okay, but
this
again,
is like you're converting back to convert again to. It's a double conversion.
No,
it's an anti-conversion and reconversion. Log is the opposite of X. Yes.
Yes.
Okay. So you also have a log divided by log, so you can reach like a specific type of. You don't need that. Let's look at the algorithm where you showed me before, where you insert the filter and do it correctly.
Okay. So let's talk math. Can you forget about the filter? This is a total math thing that needs to be like correct. So you want to say let's so you don't like that function? Let's write another function that does better conversion, but it needs to convert from 0 to
doesn't need to convert here. We start from 0 to 1. I'm looking for the 0 to 1.
I can switch. This is this function that I'm using. It's it's a custom function that takes 0 to 1 and gives you a value, but also takes.
But give me the 0 to 1. I don't need that hertz value.
No, I for this to work in a way that I can understand, I'll need the two sides. I need one function that does 0 to 1, and one function that does hertz.
You don't. You're going to do it somewhere else. I'll show you.
Forget about the filters. You're thinking about this the wrong way. I need a value for this to be usable. I need a value function in many different places in my code, including UI.
Okay,
whatever.
So
if you,
it really depends. Is it are you trying to move a cutoff or are you trying to move an oscillator? Because if you're trying to move an oscillator, you want the value to be in semitones and cents, and if you want to move the cutoff, you want it in hertz, and the cutoff in hertz, you need to just decide aesthetically where you want the center frequency to be. I told you where my choice of center frequency is. I told you what my choice of range is, like 10 octaves and E5 in the middle. That's my choice. Okay. And I can tell you how to code it into your algorithm just now. that you showed me right now.
Okay,
without the log and skew and all that stuff.
No, that I can change, but I need two. But what I need is two functions: 0 to 1 to a value, and value to 0 to 1, value in that range to 0 to 1.
You don't, but I can give it to you anyhow.
Yes, so that's where if we do it like this, I can just use it, and that will work.
No, it's going to be a bad choice. It's going to give you lots of extra calculations that you don't need. But if you want it, I can give it to you.
Yes, can you give it to me? Because that's how I can use it.
No, that's how you should not use it.
Why?
Because you only need to go one way, not the other way. The other way, you should have this algorithm only when you do the conversion from a text input in your plugin. Never besides that. The log part, you should not use in your DSP.
Okay, why not?
Because there's no need for it. If you're using it in your DSP, that means that you're doing an extra conversion that you shouldn't have.
Okay, can you start by giving me the numbers, the calculations?
First of all, the calculation from 0 to 1 to hertz, right?
Mm-hmm.
So you want to start writing it somewhere?
Yeah.
Go.
So the way this usually works is something like normalized, right? Normalized to hertz.
No.
And what?
Normalized is a thing. It's not. You're not giving it normalized. Normalized frequency is something completely different. Normalized frequency.
In my code, normalized is 0 to 1. We can also do.
No. Normalized is 0 to 1. But normalized frequency is the actual, if you just multiply it.
To frequency. Normalized to frequency.
There's nothing like that. Normalized frequency is a thing.
Right, but this is not a normalized frequency. This is normalized, normalized values 0 to 1 to frequency.
I would call it a cutoff parameter to frequency or something like that. Normalized frequency is a thing.
Okay,
so you can say double param, right, or value or whatever.
So this needs.
There's no minimum.
What about 0?
There's nothing like that. You just put in the value and you'll get out the right values. Val.
Okay. What do you mean? What do you mean? But it's 0 to 1. It's a range. I'm confused.
Val 0 to 1. Value. How do you want to call it? Param?
Val 0 to 1. But.
Okay.
And then.
That's it.
But.
You can also add another one. That's called the center frequency. In hertz, if you want.
Okay. That I can. But how do you know it's gonna? And
you can another one, center frequency in hertz. Give it a default value of.
Default? What do you mean a default?
Yes, default value. You'll be able to change it when your muse sets on you, but usually just keep it at that value. It's the best value. It's the best.
Okay.
And that value is 659.255.
Okay.
This is E5, okay? And then another value you want after another default value. Another default value in center hertz. You with me?
No, but wait. But forget about the values. I'm trying to. I want to see how this function will work to me with.
But you need another default value over there.
What do you mean another default value?
After double center hertz.
Okay.
Write a comma. And double. Range in octaves.
Okay. What is it? I'm confused. What does it mean?
It will give you the range in octaves of the parameter. range in octaves, and the default value is 10.
Okay.
Okay? So now you have no magic numbers. And here you go, return
Mm-hmm.
std exp2,
Mm-hmm.
and then you say val times range octave, val 0 to 1,
Mm-hmm.
times range octave,
Okay.
and outside of the parenthesis, you multiply it by center hertz. That's it. You're done.
That's it. I'm done.
Now you have between 20 hertz and 21 kilohertz range.
Okay.
Now you
good.
want the opposite,
Yes.
but promise me you're not going to use it inside your DSP, but only to convert when somebody writes a hertz, it will move the knob to the right place. Promise me.
I'm not promising anything. I'll use whatever I like.
Please don't. Okay. I'm going to give it to you. One moment.
So this is going to be.
Where is it? Param pitch. Okay.
So for these, I would need to pass in the same thing, but but this should be frec.
Now it's going to get frequency in hertz.
Yes, frequency hertz.
And you can do the same for normalized frequency. I could give you a different algorithm. So frequency in hertz divided by the center frequency. All of that within, you put std log around it, log 2. You divide that by the octave range. One moment. And that's it, I think. Yep. This should give you the...
Okay. So now we need something. I'm gonna copy this into somewhere else. Okay. So good. Now, here's what I'm going to do. I'm going to put it in and we're going to see the range of values that I'll try to convert this to something that's actually that I can understand, that's usable for me. So let's see.
I'll be right back.
Okay, let's try to convert this to this. Okay. Now.
I'm with you.
Okay. I want to construct a range that's usable in a parameter with those functions.
Oh, I made a mistake. One second.
Mm-hmm.
David is correct. I made a mistake. We need to change and subtract half the octave range.
Where?
One moment. First of all, in the exp2,
Mm-hmm.
you want the val 0 to 1. Put it inside parentheses and subtract half from it.
Again, where?
In line 50.
Mm-hmm.
Because I use from -1 to 1. That was my mistake. Val 0 to 1, put it in parentheses and subtract half from it. Minus 0.5.
Like that.
What is the T? Oh, type, right.
Right. Okay. So.
And in the other one, I'll give you the calculation too. Good job, David. In the other one, let me just make sure that I don't give you something bogus.
Sorry.
And do the actual calculation. Divide by the octave range. Oh, so at the end, you just add half. In 58, add to all of that half. Half plus 0.5 plus.
So after this, plus 0.5.
Yeah, you can do that. Or just put the 0.5 in the beginning and lose the parentheses. For easy readability.
Like this.
Yep.
Okay. Now we can test it. Hang on a second. So I need to construct this with the minimum, maximum, and these functions. Right, I think that should work.
Yeah, it works.
No. I'm not talking about your math. I'm talking about the start and value. Oh, sorry, my mistake. So this should be this function takes 3 values. So start end. Okay, so I can just get rid of start end here. Okay, let's see if I got this correct. Okay. Think about this for a second.
Magic cutoff.
Yes, magic cutoff. The param something parameter. The problem with the what you need is that the I in anywhere I need to pass in also the minimum and maximum. So I need to. So what I did so far is that I'm getting the minimum and maximum from your function, with 0 to 1. But
why do you need the minimum and maximum?
Because the parameter needs it. That's
Why?
how it works. Why? Because the parameter needs a number to be in the bottom.
Oh, like to display.
Yep.
Yeah, well, you can just get a min and get max.
Yeah, so I did that. I have functions that give you the minimum, but the thing is, I need to I need to construct the correct range to get the right minimum and right maximum for whatever center frequency and octave range.
Yeah.
Uh,
So for me,
mhm.
for my plugin, the minimum and the maximum on the display is displayed by octaves, not by hertz.
Okay.
I think it's more musical.
Okay, but I don't think it matters. You still need the number.
Yeah, minus 60 plus 60.
What, on cutoff?
Yeah.
I don't know. I don't know about that.
60 as in 5 octaves and semitones.
Yeah, no, I don't know about that. I want to display hertz. So
That's fine. Be like everybody else.
Be like everybody else. By the way, it just makes the calling convention just a bit weird. So let's see. Because I need to get the range like a million times, and
just do it. Do the calculation once and save it somewhere. Cache it.
Yes, but it's not so easy because it's in the constructor and it's a different range. So this takes different ranges, right? This would actually take something like center frequency and the.
Ooh, I got some emails from Julius Smith. Wow, a lot of emails. All right.
All right. Yeah, this makes this inheritance pretty hard, just because of the calling convention. Let me think about this. Okay, you know what? This could actually work. So I can actually do this. When do I get access to this? That's weird. This should work. Utilities. Yeah, this should be there. Why don't I have access to this?
I didn't get a solution. It was like, cool phaser. I would keep it as is unless your users are more demanding than they are. By the way, there's nothing stopping you from calculating these things on compile time unless you're going to add some weird tunings.
What things?
The
I need to
minimum and maximum for yourself. Yeah.
Yeah. The minimum, whatever, I can make it in compiler. It's not that's not an issue because that's the minimum maximum are only calculated once and then they're stored. So what I do is audio parameter float. That's going to take ID name to and then okay. Something like that. It's going to look.
But you don't really need to extract the hertz values
What do you mean?
from the parameter itself.
What do you mean?
Just for display. That's it.
Sure, but that's how the system works. And also, I need.
Not for DSP.
No, I do need it for my the way my filter works. It takes hertz in the frequency.
That's fine. It should take hertz, but the cutoff knob, but it shouldn't take the hertz from the cutoff knob.
But I have the same filter used not with modulation. When I'm using the filter regularly, it has to take it from there.
No.
What do you mean?
The knob is part of the modulation.
No, but I have filters where there's no modulation. Zero, just cutoff.
That's the modulation. Everything goes through that algorithm. So you don't want that algorithm to run twice or 3 times. There's no reason for that.
It's not running twice or 3 times. It's running whenever I need the frequency of 0 to 1. Just once.
No.
What do you mean?
Everything needs to be funneled through that exponent.
Sure, but in this case, in not in this case of the synthesizer, but in the case of the standalone filter, there's just cutoff.
I'll explain in a different manner, okay? You can take that, you're doing the exponent to get the frequency, and then multiply that by another exponent that you get for the LFO and the envelope. Or instead of doing it twice, you can do it just once and do it cutoff knob plus note plus envelope plus LFO. All of that exponent 2 times the center frequency. That's it. Got it? You can do that exponent 20 times.
But it's fine.
But you shouldn't.
I think you're getting too micro when you don't really understand how my code works. But I appreciate the.
It has nothing to do with how your code works. It has to do with how code should work.
I think you're. I don't think it's true. Like you need conversions in many different places in the code. In the DSP for efficiency, you're calculating them once, but you still need the math to be correct in both sides. But I think I understand what you're saying. But now I just need a second so I can actually test your math and see what it does. So let's see. So how do I call this thing? And this needs to take, let's say there's the default. So default would be something like 28,000 or something.
The default is the center frequency.
I don't agree. No. In most of my, I think in most filters.
Oh, you want it open?
You want it
21
open,
kilo.
Yeah, that doesn't matter. I just need to see that it compiles and see what the math is. So see if this is correct. It's probably.
Why don't you just give it the default in normalized values, like 1, and that's it?
It's just not how it works. In Juice, not in my code. They expect. I agree. It would be nice if they didn't accept like this. Oh, T. Okay, let's have a look and see what we got here. Okay. Okay.
Woo!
I hate these juice knobs. I need to fix this. I like it.
Especially if you're in bass frequencies, you're kind of in the middle of the range, but in bass frequencies, it gives you the.
It's an intro. I don't think it's very it's a very standard range, but it sounds pretty good.
This is the standard.
You think?
There are some synthesizers that move the center to C, and when it's open, it reaches 16 kilohertz. You see that a lot. But more or less, this is more the standard than just curving out a normalized frequency. Now the envelope is moving the cutoff 0 to 1 thing?
The envelope, yes, but it can also be negative because it says amount negative.
Yeah.
Like if the amount is going to be 1, then the envelope is going to move 0 to 1.
Okay, so let's do something cool. Do you have some noise there?
Yeah.
Add. Oh, I still hear the saw. Remove the saw, just only noise. And remove the envelope completely.
Mm-hmm.
Do you have double click to zero it? Because I see a little bit.
I don't know, because again, this is just generic UI, but can I do alt? Okay, yes.
Okay, let's push a lot of resonance. Do you have an LFO there, or
no, not yet.
Uh-huh. Okay, put it in the center so we can actually hear a pitch. Good.
Mm-hmm.
Is this like filter one after the other with the, okay. Yeah. Okay. So now let's put the envelope amount.
Mm-hmm.
It goes up to 1, right?
Yeah.
So 0.1 should give you an octave. No attack. You don't need an attack. Yeah, there you go. You can hear the octave.
I don't know if I can hear a definite pitch, but it's interesting.
Dee-doo. Add more filter strength so you can hear more pitch. That's controlled modulation for you. Now you can set the filter envelope amount to be times 10 in terms of range, and you'll get it by octaves. Or times 120 to get exactly semitone control over your filter cutoff.
Very interesting.
Now you can actually add the note numbers divided by 12 to the cutoff, and you have pitch follow.
Okay, I'll still have to think more about this part, but let's see.
And you have more control over the range of the pitch modulation, pitch bend, because you can multiply each side by a different number. Why did you decide to make a synthesizer?
It's just a utility synthesizer.
So you can test out things?
No, it's for the user. It's because I've explained this on the stream, but no, it's just that I just wanted a utility synthesizer because I wanted that people that open the plugin and have no plugins installed will have some sounds, right?
That's very nice of you. Very considerate.
Yeah, it's not going to be a great synthesizer. The idea is that it's just going to. I just did something that I wanted to make a few sounds, right? So I don't know if you noticed, but I wrote a lot of plugins. I wrote like 5 plugins today. So there's a there's a velocity curve plugin that has like this and it can do velocity curves and different curves and stuff like that. And there's I wrote a transpose plugin, which sounds obvious, but it can do.
Is this the division type curve?
What's a division type curve?
The same one that's in Gatekeeper?
No. I don't think it's the same curve as in Gatekeeper.
Can you do the same curve for the other side exactly? Does it look exactly the same when you curve the other side?
I think I remember. Let's see. So velocity curve. What do you mean the other side? Does this?
Yeah, it looks exactly the same. Okay, cool. Or maybe it's an exponent curve.
It's an exponent curve.
No, it's an exponent curve. I see it's not the same.
Yeah.
You see how it's not symmetric to the bottom and the right?
What do you mean?
You see that?
Yeah.
Go all the way to the. You see, there's more gap between the right and than the bottom.
Yes.
Yeah. So I can give you a curve that doesn't do that if you want.
Yeah, like a symmetric curve.
Yeah.
Sure, yeah. we can try that. Anyway, so what I did is I wrote a few plugins that will come with the thing. So one of them is the other one is transpose, which sounds obvious, but one of the things that this transpose can do is that if you hold a note, right? So it deals with there's no stuck notes and stuff like that. It knows to re-trigger the notes and the new transpose.
It's the Jordan Rudess transpose.
Yeah. You can use you can use one note
where he gets to one key and then starts playing a melody with just
the octaves. Kind of
like his demo with the keyboard that gets shorter and shorter. Then he starts play melodies with just the transpose.
Yeah, actually, Luis Cole does it a lot. Where he plays with the octave up and down.
Yeah.
Anyway, so I made this plugin, and then I made a couple of processing plugins. They're just filter, the same as the one with the synth, and then a clipper. So these are just plugins that I did for. I wrote all of these today. Like the idea is that these are plugins that, let's say you have no plugins, you can still make sounds, and you can see how everything works in the machine. So you can. So I wanted to you'll have at least 2 plugins in each of the slots and at least 1 synthesizer. That's the idea. Yeah, because I knew that many people would install this and maybe they don't have VST3 plugins yet, or they didn't scan anything just yet, or whatever. And I didn't want them to open this and say, oh well, I can't use this, it doesn't work, or something.
All right.
I think it's going to be also for testing. Like it's let's say you don't have any effects installed or media effects. Like it's very likely that you won't have any, so that's going to help people. Learn what a MIDI effect is, because all these internal plugins, like you don't need to install them; they're built in.
Yeah.
So they're not separate files; they're in this file. There's no way you won't have them. That's the real thing.
It's nice.
Yeah. So so the synth thing is just meant to be something that.
So let me get this straight. You're coding a free plugin.
Oh,
Whoa.
sorry. Yes.
You're coding a free plugin
Mm-hmm.
which has more free plugins in it.
Yes, probably. But those are really basic utility plugins, right? It's, the fact that we're calling those plugins is kind of, I mean,
But those plugins you're not giving for free.
What?
You're not giving the other plugins for free. Only this plugin is for free.
Again, what?
You're releasing a free plugin
Mm-hmm.
that contains more free plugins,
Yes.
but the fractalized free plugins, the free plugins within the free plugins, are not going to be free. I mean, they're going to be only in the free plugin.
I mean, yeah, I mean, we'll see. I mean, maybe we'll find a way to do the velocity curve as its own plugin. But I'm just saying it's more like a.
Pretty sure it's going to be handy for people like me that use Logic and have a very easy access to MIDI plugins.
Sure. So it's possible that we'll decide to do that. Like
I would probably download that before I download this because I'm not a keyboard player so much, but I will appreciate changing the curves to already playing sequences.
Sure. I don't disagree. So maybe this will also be something we'll release.
Yeah. And the transpose, no, I don't need it because I have it in Logic, but I can see how handy it is for live.
Yeah, none of
Does
these
the
is
transpose plugin have like a nice keyboard shortcut?
It has not. It has nothing. There's no UI. It's just like something with two knobs. I don't know. We'll see how much UI is going to go.
It would be nice if you just push buttons, numbers to change octaves and plus and minus.
Yeah, sure. Like it, you can do a lot to make a lot of these like the really cool. But again, it's utility. It's not meant to be.
Yeah.
It's not meant to be. It's meant to be something that. Because here's the thing. Like a lot of people will say about velocity curve, they'll say, hey, most of my synth or pianos, wherever, they have it, right? They already have velocity curve.
Do they?
Some of them do, yeah.
Most of my synths don't.
Really?
Yeah.
Interesting.
Yeah, maybe Spectrasonics does, but I don't know, the Logic synthesizers don't.
Interesting. Okay, that's good to know.
Or if they do, it's like hidden inside some kind of modulation menu that you have to kind of remove the velocity and reapply it through some kind of modifier or whatever.
Right.
Just change the MIDI. I'm happy.
Yeah, sure. I mean, what we found is that most people don't really know how to approach MIDI effects. It's weird for them. They don't understand the connectivity of it. That's one reason why we made this, is because we realized that I know in Logic there's a box that says MIDI effects, but most people don't know how to use it.
In Logic, maybe it's the most approachable implementation of MIDI plugins from all of the DAWs.
Yes, but the thing is, because there aren't a lot of MIDI effects, people are not used to go there.
They don't even know it exists. Yeah.
Yeah, that's what I'm saying. Like, one of the reasons why we did this, to me, is a lot of the reason why this exists is the layout. It says, hey, put a synth here. There's going to be a visualizer here. Like, it's going to look like this. But the idea is that when you make your synth, put MIDI stuff here and put effects here. Like, this is how you should work. Mm-hmm. This is really the reason why this exists, because we want to tell people, hey, when you make a synth, it should be so easy to say, hey, arpeggiator here,
yeah.
And it's not easy right now. Like, it's not obvious. You're not used to going there. It's weird. And Logic make it, like you say, they make it really easy, but nobody knows that it's a thing. And we wanted to kind of put it in front of your eyes and say, hey, MIDI effects, it's cool. Try it.
Yeah, and also Logic, the fact that it's easier on Logic than the other DAWs exactly shows the point where it's terrible on 90% of the DAWs.
Yes. And by the way,
it needs to be addressed.
Yes, and by the way, there's also technical problems in most of the DAWs, because some DAWs, because they use different tracks, they sometimes introduce latency when you're they do like buffer latency when you're patching MIDI effect, and this has no latency, which is important.
Which brings me to another question.
Mm-hmm.
Will this be able to transmit sysx messages?
Sysx messages to do what?
To control my hardware synthesizers.
But, I mean, oh, you mean like if I put a MIDI effects here that sends out sysx?
Yes.
I don't filter them. They should be going through. We need to test.
Please do it.
I mean, we're not filtering anything in. I need to check if maybe if there's a bug, we'll solve it. But as far as I understand, we're not.
If you're going to fix this for Logic, that's going to be one of my most used plugins.
Yeah. So it will. It will work for that because when you, I don't know about what Logic gives the plugin on the input side.
In the MIDI, I've tried to make a MIDI controller for my Super Jupiter, the Roland MPG 80 or MKS 80.
Okay.
And it filters out my sysx, so I can't transmit sysx to the synthesizer, and it's just annoying. But if you can, if I can load like the external synth, can you do that? I'm not sure if you can.
What?
I need to send this to an external synthesizer and get that Logic has. I'm not sure you can.
No, this would send MIDI. Right. How to take MIDI? I need to remember, but I think you can do this. There's a Logic does as a thing of taking the MIDI out. I forgot how they do that. But here
they have an external device instrument.
Yeah, for some reason this doesn't show the MIDI out, but at least the standalone here should show the.
Standalone should do it for sure.
Yeah, I don't know why it doesn't. I need to fix that. But anyway, Logic also has this thing called IAC. Apple has this thing called IAC, so you can use that to send MIDI out. Yeah, but like you said, external instrument, that thing should work.
It would be awesome.
Yeah. So David says in the most recent Logic updates, you can route from one channel to another external MIDI track if you want. Right.
Yeah, but the problem is that they filter out the sysx.
Yeah, the sysx thing we need to figure out. I don't know if this is going to work in the Logic output, but yeah, I don't know if I have a solution for this particular thing because I don't know if we can. What can we do within Logic?
One step closer.
One step closer. I'm to think about it. All right, Asaf, thank you so much.
Thank you, and listen. Put everything into that algorithm. Don't do it like 5 times in parallel and multiply it by one another. Okay, it will help you think in semitones and cents instead of frequencies, which we should be doing.
Right.
Generally speaking. Just like we should not be thinking in a normalized amplitude, we should be thinking in decibels. We should not be thinking in frequencies. We should be thinking in pitches.
Yeah.
That's it.
It's hard for me.
You're a musician. All right.
I know how it sounds, but it's hard for me to think of like the connection between numbers. That's the hard part.
I think once you get into that zone of insisting to work in pitches, you'll feel much more at home than frequencies and hertz and all that shenanigan. It's just not as natural. It's not as musical. And if you just do that conversion in the end, you'll be liberated from crazy conversions, back and forth, log, exp, all that stuff. There's no need for it.
Nice.
Instead of multiplication, you just do addition. So you already see how much calculations that can save you.
Right.
Whatever was power becomes multiplication. Whatever's multiplication becomes addition. It takes all of the complexity down a level.
That makes sense.
That's the difference between pitch and frequency. In pitch, we add. In frequency, we multiply.
Yeah.
That's it. Okay.
All right.
Bye. You're the
Bye.
best. Good luck.